Hello everyone, welcome to IB Math Solution. Today we'll be solving problems from review set 2B. So let's get started. Problem 1. List the subsets of this set. Now we know there are 3 elements in this set. So first we'll list all the subsets with 0 elements. 0 elements in it. So what will that subset be? An empty one, or represented by this symbol. Now all the subsets containing only one element, that is going to be 1, 3 and 5. Now we'll take all the subsets containing exactly 2 elements. Exactly 2 elements. So that is going to be 1 and 3, 3 and 5, and 1 and 5. Now we'll write all the subsets containing exactly 3 elements. That is going to be this set itself. And all these sets is what the question is asking. We have listed all the sets. Let's go to the next question. S and T are disjoint sets. So disjoint sets are the sets that do not share any common part. So when it says the number of elements in S is equal to small s and the number of elements in T is small t, find S intersection T. So we know that they don't share any common part in between them. So S intersection T is going to be a null set, and number of elements in S union T is going to be the number of elements in S plus the number of elements in T minus the number of elements in S intersection T according to the formula. Now this is small s, this is small t, and this is 0 from here. So this is going to be S plus T, and that is our answer. Let's go to the next question. Write in interval notation the real numbers between 5 and 12. So this is going to be x is a set of real numbers such that x is greater than 5 and less than 12. So we have done this. The integers between -4 and 7, including -4. So we know integers are denoted by this symbol z. Therefore we can say x is an element of integers such that x is greater than or equal to -4 and less than 7. This is our answer. C. The natural numbers greater than 45. So x is an element of natural numbers such that x is greater than 45. This set is our answer. State whether each set is finite or infinite. So from here we can say this set is going to be infinite because there are an infinite number of real numbers between any two numbers. This is a set of integers, so this is going to be finite. This is a set of natural numbers and it has to be greater than 45. So we know greater than 45 there are an infinite number of integers. So this is also going to be infinite. Let's go to the next question. Write in interval notation. So we know we are talking about real numbers as we have a line here, line segment. So we can say x is an element of real numbers such that x is greater than 2 and less than or equal to 5. This is A. Here we know we have dots, so this can either be integers or natural numbers. So, and we know all these numbers are positive. So between positive 4 and positive 9, we have positive numbers only. So let's consider that these are positive integers. So x is an element of positive integers such that x is greater than 4 and less than 9. See, now we know we again have lines. So in case of lines, we know that it has to be a real number. Therefore, we can say x is an element of real numbers such that x is less than or equal to -3. Union x is a set of real numbers such that x is greater than or equal to 1. So this is our answer. Let's go to the next question. Let S be equal to a set of integers such that those integers lie between 2 and 7, including 7. List the elements of S. So S is going to be 3, 4, 5, 6, and 7. Display S on a number line. So let's draw a number line. So the elements of S will be from 3, including 3, 4, 5, 6, and 7. This is S. Find number of elements in S. So number of elements in S is equal to 1, 2, 3, 4, 5, 5. Answer. Let's go to the next question. Determine whether A is a subset of B. So in order for A to be a subset of B, all the elements of A must be present in B. Now let's first list the elements of B. B is a set of integers such that those integers lie between 0 and 10. Therefore, this is going to be 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, are the elements of A a part of B 2, 4, 6, and 8? Yes. Therefore, we can say yes, A is a subset of B. A is an empty set and B is any set, let's say. So an empty set is always a subset of any other set. Therefore, we can say yes, A is a subset of B. A is this set, B is this set. So B is a set of real numbers between 0 and 4, including 0. And A is a set of rational numbers between 2 and 4, including 4. Now we know that 4 is a rational number, but 4 is going to lie in set A only, not in set B. Therefore, we can easily discard and say that A is not a subset of B. Because of 4. We do not have to check anything else. 4 is a part of A but not a part of B. A is a set of real numbers less than 3. B is a set of real numbers less than or equal to 4. So let's draw a number line. Now A is a set of real numbers less than 3. So A is going to be this line. This is A. And B is going to be a line starting from 4. This is B. Now is A falling inside B? Yes, we can say that. So yes, A is a subset of B. That is our answer. Let's go to the next question. Find the complement of X given that the universal set is a set of 7 colors of rainbow. So what are the 7 colors of the rainbow? That is violet, indigo, blue, green, yellow, orange and red. These are the 7 colors of the rainbow, and X is a set containing red, indigo and violet. Now this red is present here, this indigo is present here, this violet is present here. So we can say X complement will be all the elements of the universal set that are not a part of X. So this is going to be B, G, Y and O. Blue, green, yellow and orange. Universal set. This one is a set of integers between -5 and 5 including both. So let's first enlist elements: -5, -4, -3, -2, -1, 0, 1, 2, 3, 4 and 5. X is equal to -4, -1, 3 and 4. So which elements are common? This is common with this one, this is common with this one, this is common with this one and this is common with this one. So X complement is going to be all the elements from U that are not present in X. -5, -3, -2, 0, 1, 2 and 5. This is our answer. C. Universal set is a set of all rational numbers. So this universal set is the set of all rational numbers. X is the set of all rational numbers less than 8. Less than -8. Therefore, X complement is going to be a set of rational numbers greater than or equal to -8. Therefore, we can write it X complement is a set of all rational numbers that are greater than or equal to -8. This is our answer. Let's go to the next question. Let U, that is the universal set, be a set of all integers between 0 and 10. So U is going to be 1, 2, 3, 4, 5, 6, 7, 8 and 9. A is the set of even integers between 0 and 9. 2, 4, 6 and 8. B is the set of the factors of 8. 1, 2, 4, and 8. Now the question says list the elements of A. So this is part 1. The elements of A intersection B. Now we know 2 is a common element, 4 is a common element, and 8 is also a common element. Therefore, elements of A intersection B is going to be 2, 4, and 8. The complement of A union B. The complement of A union B. Therefore, this is going to be, what is A union B? First, we need to find out the elements of A union B. Therefore, A union B is going to be 2, 4, 6, 8, 1, and that's it. This is going to be A union B. Therefore, what are the elements of A union B that are not present in the universal set? So first we need to find the common element. So this is a common element. This is also present here. This is also present here. This is also present here. And this 8 is also present here. Now, to find the elements of A union B complement, we need to find all the elements of the universal set that are not present in A union B. So those elements are going to be 3, this one, 5, 7, and 9. This is our answer. Section B, represent this information on a Venn diagram. This is set A. This is set B. Now we know A intersection B is 2, 4, and 8. A contains 2, 4, 6, and 8. 2, 4, 8 have already been considered, therefore only 6 is remaining. B contains 1, 2, 4, and 8. 2, 4, and 8 have already been considered, therefore only 1 is remaining. And from this universal set, 1, 2, 3 has not been considered, so 3 is going to come here, 5 is going to come here, 7, and 9. Now this is the Venn diagram the question is asking us to make. So this is our answer. Let's go to the next question. Consider the sets U, that is the universal set. It is a set of positive integers less than or equal to 40. So let's first list the elements. Positive integers start from 1, 2, 3, 4, 5, and so on till 38, 39, and 40. Set A contains factors of 40. 1, 2, 4, 5, 8, 10, 20, and 40. Set B contains factors of 20. That is 1, 2, 4, 5, 10, and 20. List the sets A and B. So we have already done this. What can be said about sets A and B? Set A and B, we can see that all the elements of B are present in A. Therefore, we can say B is a subset of A, or rather, we can also say B is a proper subset of A. We have done this. Section C, illustrate sets A and B on a Venn diagram. As we know, B is a subset of A, so B has to come inside A. And the elements of B are 1, 2, 4, 5, 10, and 20. And the elements of A are 1, 2, 4, 5, 8, 10, and 20 we have already taken, and 40. Now the elements of the universal set that are not considered yet will come here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, and 39. This 40 we have already taken. So this is the Venn diagram. So this is our answer. Let's go to the next question. Consider P a set of all integers between 3 and 10, including 3. So we can say P is a set containing 3, 4, 5, 6, 7, 8, and 9. Q is a set containing 2, 9, and 15. R is a set containing multiples of 3 less than 12. Therefore, 3, 6, and 9. List the elements of P. We have done it. Write down the number of elements in P. So the number of elements in P is going to be 1, 2, 3, 4, 5, 6, and 7. State whether P is a finite or infinite. So we know there are a finite number of elements in P. So we can say it is finite. Explain why Q is not a subset of P. Now the elements in Q are 2, 9, and 15. We can see that this 2 is not a part of P. However, 9 is a part of P, and also this 15 is not a part of P. Therefore, we can say as 2 and 15 are not present in P, therefore Q is not a subset of P. Explain why R is a subset of P. Now we can see that R has 3 elements, 3, 6, and 9. They all are present in P, 3, 6, and 9. So we can say as all the elements of R are present in P, therefore we can say R is a proper subset of P. List the elements of P intersection Q. So P intersection Q, these two sets have only one element in common, that is going to be 9. R intersection Q. R intersection Q. R and Q have only one element in common, that is 9. R union Q. R union Q. Therefore, R union Q is going to be 2, 9, 15, 3, and 6. Let's go to the next question. On Venn diagrams like the one shown, shade the regions which are described by A union B complement intersection C. So we know A union B is this whole region, this region. So let me mark it. And its complement is going to be everything outside this region. So its complement is going to be all this region. Now we have to find this region intersection C. So this region intersection C is going to be this part only. Therefore, we can say the question is asking us to shade this region. Or in other words, we can read this as C but not A union B. So we know C is this part, and out of this part, this white region is the part of A union B. So C but not A union B. So we have done this. B. C complement intersection B. C complement is outside this circle. So in other words, we can read it like B but not C. B but not C. So everything inside B and outside C. This done. Now A intersection C but not B. A intersection C is this whole region, this region. Now the question says A intersection C but not B. So from this region, B is this part. We can say the question is asking us only this region, A intersection C but not B. So this is our answer. Let's go to the next question. In a car club, 13 members drive a manual car. So number of people driving the manual car is 13. 15 members have a car with sunroof. Number of members having a car with sunroof is 15. 5 have manual cars with a sunroof. So number of members with manual car along with a sunroof is 5. And 4 have neither. So number of members that do not have either manual car or a car with a sunroof is 4. This number can also be written like the number of members in M union S complement. We can write this term as this one as well. So this is for manual car, this is for car with sunroof, and we know the intersection has 5 members. Manual cars 13. 13 minus 5 is going to be 8. Sunroof cars is 15. 15 minus 5 is going to be 10. And members with neither of the cars is 4. Display this information on a Venn diagram. So we have already done that. How many members are in the club. So that is going to be 8 plus 5 plus 10 plus 4. This is going to be 15 plus 12, 27. Drive a manual car without a sunroof. Manual car without a sunroof. This part is going to be subtracted. Therefore, 8 is the answer. Do not drive a manual car. So everything outside this region is going to be our answer. That is 10 plus 4, 14. Let's go to the next question. All of the 30 students on a camp left something at home. 11 forgot to bring their towel. So number of students who forgot their towel is 11. 23 forgot their hat. So number of students who forgot their hat is 23. How many had neither a hat nor a towel? So we know, since all of them left something at home, therefore this number is going to be 0. Now there are 30 students in total. So number of students in T union H is 30. We know the formula for T union H is number of students in T plus number of students in H minus number of students in T intersection H. By putting the values, 30 is equal to 11 plus 23 minus number of students in T intersection H. 11 plus 23 minus 30. So this is going to be 4. Now we know 4 students are there who neither had a towel nor a hat. So this is our answer. Let's go to the next question. At a conference, the 58 delegates speak many different languages. So 28 speak Arabic, 27 speak Chinese, and 39 speak English. Therefore, let's say this circle is for Arabic, this is for Chinese, and this is for English. Now we know number of elements in A is 28. Number of elements in C is 27. Number of elements in E is 39. 12 speak Arabic and Chinese. So the number of elements in Arabic intersection Chinese is 12. 16 speak both Chinese and English. Number of elements in Chinese and English is 16. 17 speak Arabic and English. Arabic intersection English is 17. 2 speak all the 3 languages. Therefore, the number of elements in A intersection C intersection E is 2. Now we know this region is going to be 2. Now we know this region is going to be 2. A intersection C is 12. This region is 12. 2 is already taken. Therefore, 10 is remaining. C intersection E is 16. This is 16. 2 is already taken. So, 14 is remaining. A intersection E is 17. Therefore, 15 will come over here. A is equal to 28. This whole circle is 28, out of which 27, 10 plus 15, 25 plus 2, 27 we have already considered. Hence, only 1 is remaining. Number of elements in C is 27. This circle contains 27. 14 plus 10, 24 plus 2, 26. 26 we have already considered, so 1 is going to come here. Number of elements in E is 39, out of which 15 plus 14, 29, 29 plus 2, 31 we have already covered. Therefore, only 8 elements will be here. Now we know there are a total of 58 delegates. So the number of elements in the universal set is 58. And how many we have considered so far? So the number of elements in A union C union E is 1 plus 10 plus 1 plus 15 plus 2 plus 14 plus 8. That is going to be 1 plus 10 plus 1 plus 15 plus 2 plus 14 plus 8. 51. Out of the total of 58, we have already considered 51. So remaining 7 are going to come here. Now the question says, how many delegates speak Chinese only? So Chinese only is 1. How many delegates speak none of these languages? That is 7. Neither Arabic nor Chinese. Neither Arabic nor Chinese. That is going to be 8 plus 7. And this is our answer. That's all for this exercise. I'll see you in the next session. Thank you.